Hey guys, Epicenter Brian here. Hey, today is kind of a weird show and tell video, and I've got an old school original HarvestRight in here, and it's my first chance to actually see one of these. This belongs to a local customer who oddly enough just bought a new machine, but he wanted to see if he could get his old machine up and running while he was waiting for the new one to come. So I agreed to take a look at it. Because I wanted to see how it works and how it's different from the other machines. So just to refresh your memory, the original machines had a display here, but we call these dial type freeze dryers. This one dials in the amount of freeze time, and then the bottom one dials in how much the defrost time is. And then it's got a switch here that's power on for freeze drying. But then the defrost cycle, you would put the switch down in that position. I want to go over what I discovered with this machine and show you what the root cause of the problems were. Now the first thing was the customer said that he smelled burning plastic on the machine. And you can see right here heat damage on this outlet. This outlet goes to the pump. And you can also see heat damage right here on the side. Okay, so that's been replaced, put a new connector in, that's soldered in position. So while I was in the machine, I started looking over some other things, and I wanted to kind of determine, what was the root cause of that. And so another thing I discovered was a connector here that was discolored. Let's see if you can see that. Anyway, from this side you can see it's a kind of a light blue, and this side it is dark. Well, that was connected on this switch on this terminal right here. Okay, and you can see that that terminal has become discolored as well, and you can see that the plastic right here, the plastic is kind of yellow. So I went ahead and ordered a new one of those switches, and I was going to build up a cable, replace this connector on the cable. So this was one of the cables that connected to the switch, but once I started looking at this real close, and this, you might not be able to see this, but there's discoloration on the wire itself that was caused from heat damage. So I went ahead and made a new one of those for the machine, and installed that. That's 14 gauge, and it's high temperature, 105 degrees C rating on the insulation. So the next thing I looked at was the power input cord, and check this out. So here again you can see that this had a lot of heat on this connector, and it's on the side, not only the side that plugs into the freeze dryer, but it's also on the other side that plugs into the house. And I hope you can see that there, but there's definitely heat damage on this pin over here. Now I also replaced the main input connector on the freeze dryer, because on the right side you can see that there's some distortion in there, and I think that may actually be rubber from the power cord that got really hot. The rest of the connector looked okay, but out of caution I went ahead and replaced this one too. So the new pump draws about 3.5 amps when it first turns on, and then it drops down to about 2.5 amps. So that's kind of what I was expecting with the old pump. The old pump should be a 3/4 horsepower, and so let me show you what I discovered. Now theoretically, with that capped off, the motor should get to a low pressure very quickly, and if it's at a higher pressure it draws the most amount of power, and then as the pressure drops it requires less work, which means less current. Here's the old pump, and I'm going to be using this clamp-on AC current meter. I've got the pump plugged into the wall, and there's a special adapter right here that lets me clamp on and measure the current through that wire. Okay, so let me get down here real quick. I'm going to turn the pump on. Okay, and we're going to come over here. You can see that's reading almost 0. This isn't perfectly calibrated. It says 0.1 amps right now, but here we go. Clamp onto that. And now you can see that's drawing 7.5 amps. It turns out if you enter 7.5 into this horsepower calculator real quick, 7.5, and hit calculate, we're looking at almost 1 horsepower. Okay, so that motor should be a 3/4 horsepower, but for some reason it's drawing enough power like it's a 1 horsepower. Here is the new pump, and now we're going to take a look at the reading. And initially you can see that it runs about 4 amps, and then as soon as the pressure starts dropping, it drops down to about 2.5 amps. So let me just pause for a minute and I'll show you that. Okay, now that the pressure has gone down, let's take a look again. There's our initial reading, and you can see that the pump gets down to about 2.5 amps here as soon as the pressure lowers. Right now we're in freeze dry mode. We're at operating millitours and operating temperature. And again, we are actually running this pump externally. So once again, take a look here. There's no pump connected up to that connector. And we're going to just see how much power is being used now by the freeze dryer and the heaters while the pump is being run externally. Okay, so we're at 10.7 amps. Let's take a look at the data that we collected. And we need to review. This was at operating pressure and temperature. So remember that the way this really works is the freezer comes on first, and then the pump comes on, and then eventually when it gets to the correct pressure, then the heaters come on during the freeze drying cycle. Okay, so the value that we have there for the freezer and heaters was at operating pressure and temperature. Now remember, the new pump, the right column, the pump drew about 4 amps when it first came on, but at operating pressure it dropped down to 2.4 amps. Okay, and when the pump was at 4 amps, those heaters were not actually on, which is about 6 amps on their own. Okay, so the grand total power used with the new pump when everything was at operating pressure and temperature was 13 amps, and that was running through parts that were rated for 15 amps. So that's great. Now when you look at the old pump was drawing 7.5 amps, and it didn't matter whether it was at a high pressure or at operating pressure, it still drew that much power, and it should have dropped down, but it didn't. Okay, that meant when everything was running, the freezer, the heaters, and the pump, it was drawing 18.2 amps through parts that were rated for 15. That's where all the heat damage came from. And it originated from the fact that the pump was drawing too much power. Now after I've repaired the machine and figured out what the root cause was, the owner of the machine said, well, gee, what happens if my new pump does what the old pump did? Is there a way to make sure that the wires don't melt again? And I said, yeah, we can do something. So let me show you what I came up with. Okay, the concept here is to use an external relay box so that the power for the pump doesn't actually go through the freeze dryer. Now this has its own power cord, gets plugged into the wall, and then the pump itself gets plugged into this box. Now there are a couple of other things involved. There is a DC power supply plugged into an outlet that says always on. Okay, that provides DC that runs over to this little box. Okay, now this box has a small relay in it, and when it sees power, that relay turns on. It uses practically no power, and it makes a contact between these two connection points on here. So what it does is it'll route the DC out here and back into the trigger input on this external power switcher. Okay, so let me show you how this all works. First off, you're going to notice there's a power light on. That's because there's power here. You're going to see the power supply has a power light on, and that's because it's plugged into the always on. There's a light down here that you probably can't see at all because it's off. It says switch active. And then you'll see a power LED here that is off right now because there's no power on this power strip. So pretend like this outlet right here is on the back of the freeze dryer, and this is actually the freeze dryer that's trying to turn on the pump. Okay, so when I throw this switch down here, watch what happens. First off, you hear the pump running. You see a power indicator light on here. Okay, because there's power on here, it made a switch closure here, routed the DC into the trigger input, and now you see this green light on that says switch active. That means both of these outlets that are normally off are now on right now. Okay, so if we were to turn this off, like yay, you hear the pump turned off. You see that light went off, and you see this light went off, and when I turn it back on. So when the freeze dryer says turn on the pump, pump's on. And when the freeze dryer says turn off the pump's off. And it's that simple. Now the cool thing about this is with the addition of another relay and some more wiring, it means 2 freeze dryers can run 1 pump. And you know, you'd have to have the right adapters and all that, and it needs to be a good pump, you know, to be able to run 2 freeze dryers. Anyway, I'll go into more details on that in another video, but let me give you a sneak peek. Let me show you what I've got hooked up. So this is a 3rd generation. This is the 1st generation, the one that is in this video, and this is a 2nd generation. And we've got all of those running off of 1 pump. This is a Leibold pump, and it's a real industrial pump. These are not on the website, but we do sell those, so if you're interested in one of those, give us a call and we can work up a quote for you. But what I wanted to show you was, notice, we've got one of those little relay boxes hooked up in place of the pump on this freeze dryer, and we've got another one here hooked up in place of a pump, and over here on this freeze dryer there's another one of those. Okay, now all of those are connected down here to this big power switcher. Now this is an expensive unit. These are about $600 new, and that's all I could find that would do this job 3 years ago when I put this system together. So I was pretty excited to find this little unit that does the job. This will run 12 amps, and that particular pump draws 9. And we've already seen what happens if your pump is drawing too much power and it's connected up to your freeze dryer. So anyway, all the parts to put together that system I showed you earlier, we have those in stock. They're not on the website, so in the meantime, until we get them up there, just go ahead and give us a call if you need one of those, and we can work that up for you, work up the price and all that kind of stuff. So, hope you enjoyed this video. I'll do another one in more detail about the tricks to running multiple freeze dryers on 1 pump. And that'll come up in the future, so be sure to hit the subscribe button and you'll get a notice. And until then, for the Epicenter.com, I'm Epicenter Brian, signing out.